3.1, number 16. Function changes to being a radical function. Square root of x plus 8, and a equals 1. Limit as h approaches 0 of f of 1 plus h minus f of 1 over h. That will be f prime at 1, of course. Sneak that in there. All right. Equals, filling in the function rule. Limit as h approaches 0 of f is the root of x plus 8, so we have the root of, a little sloppy there. We have the root of 1 plus h in place for x plus 8 minus f of 1, so we need to plug a 1 in right here for x, and we'll get the root 1 plus 8, which is, oops, anticipating there, plus 8, which is 9, and the root thereof will be a 3. All right. Let's go ahead and simplify that very quickly before we do any more work on this. So we'll have limit as h approaches 0 of the root of, I'm going to write 9 plus h, minus 3 over h. The hidden factor of h, which we're hoping will exist in the numerator, is not clear at all. But we've seen these types of limits before. We just didn't realize they were derivatives in disguise. So we should multiply by the conjugate, root 9 plus h plus 3 over that same conjugate, root 9 plus h plus 3. And we know what will happen. I don't need to FOIL out the numerator, right? I can conclude quickly. We should end up with this root times this root, so the roots will cancel. Get 9 plus h itself, and then minus the product of these two, so minus 9. The bottom just stays how it is, h times the root of 9 plus h plus 3. So there's our hidden factor of h. We revealed it. 9's, of course, cancel. And the canceling h factors are now obvious. All right, so now the whole issue with the bottom going to 0 has dissolved. And at this point, it should be a simple direct substitution limit here at the end. Sure enough, it is. As h goes to 0, the bottom is no longer going to 0, so direct substitution is effective. This h will head towards 0. We'll have the root of 9 down here. So our answer is 1 over root 9 plus 3. That is, of course, a sixth.